Here we go. Hello, everybody. So here's our first video lesson for Wednesday. We'll go over yesterday's homework, and today we're going to learn about circles. Yeah, get a well-rounded education with circles. Okay, so let's peek at yesterday, and I'm going to switch this over to, let's see, here we go. So yesterday, the homework was you did 1 to 5 and 8 to 11. And I know it'll be a while to get the quizzes back, but because I'm not there, but we did 1 to 5 already. So I'm going to give you the answers to 8 through 11 that you can check your own work. So let's check out the 8 to 11 stuff. Let me switch over here. Okay, and this was number 8. It was the one, which point is the intersection? Now I don't have the graph to tell, but I could do a graph. But how do I tell without a graph? And says, this line y equals 3, and this line right here. Well, I'm wondering where these cross, but I could say, well, why don't we just plug these in? Okay, now this one says y is 3. So I know that y has to be 3. So just looking, could be A, could be B. Well, it's not C, that's got the wrong answer. Could be D, but which one of those works? Well, let's check out the other equation. Let's plug in 3 and see which one works. So I plug it in here. There's the y over here. I got the y. So I'll go 3 is negative 2x plus 5. And let's just see what's the answer to this one. If y were 3, because this guy says y has to be 3. So what does this guy have when he's 3? So I'll solve this. I guess I'll bring the 5 over. Subtract the 5. I got minus 2 is minus 2x, divide by negative 2, and x is 1. 1 is the answer. So x is 1 and y is 3. There it is. So choice D. I should go with letter D. And here it is actually in Desmos. Here's a graph. You see what I did? The red line that's flashing, that's y is 3. And here's the blue line. And how did I do that? I could make some points. I could have sat here and said, made a little table and put dots in, see, and tried out a few points, right? Plug numbers in to get some dots. Put this guy back the way it was. But where do the graphs touch? Right there. At 1, 3 is where the lines cross. Okay, so that's the intersection where the roads intersect. Yeah, blue has a lot of answers, but the only one where they cross is 1, 3. Okay, and go to the next question, number 9. Okay. And here's a price. Says, look at these graphs, match each graph with its equation. Well, wait, that has squares. Is that a circle? X squared, Y squared. Wait, there's a number in front. Normally this shouldn't be here. This should be just X squared plus Y squared. That would make a circle. But if there's a number in front, it makes it kind of oval, kind of squashes it down. It's or it's called, we call this not an oval, it's an oval, but we also call it an ellipse. Like you might have heard the planets are in elliptical orbits. So the blue one must be the ellipse, and this is a straight line. If nothing funny is going on, that's a straight line. And it says, okay, match them. So the blue guy is the ellipse. The other red line's a straight line, that's this one. Estimate where they intersect. Okay, well, just look at them. Lavi just said, it would be nice if they put the numbers here. -1, -2, -3, -4, -5. So it looks like -5, 0. And this other one. Now, some of you might think it's 0, 1. But isn't it a little bit above? Isn't it a little bit above 1? How do I figure out exactly where that is? 1.5? No, it's not quite 1.5. So there's also curious, is this exactly -5? So you know how I'm going to do? I'm going to plug this in. I'm going to see, does this really touch -5 or is it 4.9? So what I did, and let me get something here to cover this up. I took the equations. Let me zoom out. Here's the equation. I put -5 into them. And actually, I tried this out. If I put -5 in here, what's -5 plus 5? -5 plus 5 is 0. If I put that right in there, and I put in -5, I go, okay, -5 plus, whoops, 5 times a fourth. -5 plus 5 is 0. And 0 times a fourth is 0. Ah, it really is 0. And same thing here. I put it in and I got 0. So this is -5, 0. But the other one, it looks like it's 0 something, right? 0, but I can't tell exactly where it is. It looks like more than 1. So once again, what I did is I took the equation and I said, well, it looks like 0. Let's plug it in. Is it 0, 1? I don't think so. Let's see. So it's just like someone's like, okay, let's just plug it in. Let's just plug in 0 and see what we get. So here's my work. I plugged in 0. 0 plus 5. See, what do we get? 0 plus 5 is 5. 5 times a fourth is 5 fourths. Oh, 5 fourths, or 1 1/4. It was a little bit above. And let me check the other one. Let me just see if I still get the same thing. Here was the ellipse. So I put in 0, and let's see if I get the same answer, just to make sure they both have the same answer, that they really touch there, they cross there, they intersect there. Okay, so I put in 0. 0 squared is 0. So that's gone. How do I solve that? Well, wait, divide. Divide by 16. Cross that out. So now I got y squared is 25 over 16. Now, how do I get rid of a square? Square root. Square root will wipe out a square. And then the square root of this, just do the square root of the top and the square root of the bottom. The square root of 25 is 5. The square root of 16 is 4. It's the same answer. So that's where they do touch. They do touch at 5 fourths. Okay, so they touch at -5, 0. And they touch at 0, 5 fourths. So it was a little bit above. Okay, it took a while. Number 10. 10 said, find the intersection of y equals -2. Okay, so here's my graph paper. Y equals -2. Now I don't need graph paper to do this. I can't see the question. I'm stuck here on the table. There we go. Find the intersection of y is -2. Okay, like 1, 2, these are the y's, -2. So some line like this. And for every one of these, so I said, okay, where's x is 0? Okay, here's x. 0, x is 0 is like right here, up and down. And x is 1, well, that's 1, that's right here. And x is 2, and x is 3, and x is 4. So it looks like they touch here and here and here and here and here. In fact, wait a minute, I got a little shortcut here. They told me y is -2, didn't they? They said y is -2. And they told me what x is. They said like x is 0, then x is 1, and x is 2. If y is -2, don't the intersections always have to be at -2? And if x is 0, they must cross at 0, -2. If x is 1, if x is 2, if x is 3, if x is 4, actually I have the answers. These are the x's and these are the y's. So each one of these I can go, where do you cross? Well, I have to be 0 and I have to be -2. That's where we cross. I have to be 1. I have to be -2. I have to be 2. I have to be -2. So you can go right down the list and that's where they all touch. Okay, number 11. Oh, I don't want to, do I have to graph all these? It says, where does x equal -1 cross these? You know what I'm going to do? I'll do the same idea. I'm going to say, okay, well, x has to be -1. So what's y? So I plugged it in. So let's see what I get. And it's like, you might think this takes a long time, but every one of these is the same answer. So I put -1 in. So I just took this first equation and I said, okay, let's see what happens when we put in -1. -1 plus 1 is 0. 0 times 2 is 0. What minus 3 is 0? 3. Oh, so they must, x must be -1 and y is 3. So in fact, they were all -1, 3. Every one of those was -1, 3. Okay, so kind of tricky, sometimes confusing. We're going to go into the next lesson, and I'm not really going to use the book here. I put some stuff on the screen, so let's get this back over here. And I'm going to bring up the slides. Okay, and switch this over. And that's what we already did. Where are we? Okay, just a moment. Okay, so today we got our circles, and we learned about circles before. And let me look for a pen to write on this screen. Where did my pen go? Okay. Okay, so here's the circles. So we had, remember the orange poster over on the side of the board? There's x squared plus y squared is 25. We learned whenever we see this x squared plus y squared, we're like, circle. Okay, we're just say that's a circle. But then I look, I say, so I got that, it's a circle, and I know all we had to do was just look at this last number and go, okay, that's supposed to be, I'll do it in blue here, that's supposed to be r squared, and r is radius. I'm trying to write on the laptop screen. So radius, I know that doesn't look very good. Okay, so the radius, and we go, what squared is 25? That's like 5 squared. So that's why I got this circle right here at 0, 0, and it goes up and right. Every one of these is 5 away. That's 5, that's 5, that's -5, and that's -5. So everything was 5 away. It also asked, like, are any of these points on the graph? Well, remember we did this before? We did 3 squared, 4 squared, 5 squared. We put in 3 squared and 4 squared and said, hey, that's 5 squared, isn't it? That actually works. That's 9 plus 16, which makes 25. So we said 3, 4 works. In fact, I can see it right here. There's 3, 4. It'd be nice if they would put the numbers in there for us. Okay, I can't write on the screen too well, 3, 4. But what about these other ones? This guy works, -3, 4, -3, -4 is over here. I'm trying to get the right. That one works also, because when you square a negative, I'm trying to write on the laptop screen, doesn't do too well. Okay, because you can still get 9 and 16, because even negatives, when you square them, they turn positive. But what about this other ones? You might say 4.9 and 1. Look at right here. Is that 4.9 or is it 5? And you could like, well, what if I took a calculator and put that in there? And I put 4.9 and 1. So if I go like this and go, okay, I'm going to switch this. Boom, boom. If I took this calculator and go, okay, 4.9 squared plus 1 squared. Will this make 25? It's close. It's close, but not quite, is it? I think it should have been 5 squared plus 1 squared. No, that's too much, isn't it? It was close, but not quite right. Let's switch back here so we can see that. Yeah, so in fact, I didn't quite get that circled right, did I? Right here was 4.91, but no, it's close, but not quite right. I know you're looking at that and you're saying, is that 4.91? But not quite. This one's good. 0, 0 doesn't work, and this last one doesn't work. We could sit there and keep trying them all, but these work. But our main thing is, can we just draw these? Okay, so if I said draw the circle, what if I said x squared plus y squared is 36? And you just go, oh wait, what squared is 36? So we still got a circle, but his radius is 6. And so you would do the same thing. You start in the middle, try and get that to draw. You'd start right there and just go over to 6, and then left 6, and then up 6, and then down 6, and then try to make a circle. And last one, of course, what would this one be? It says 49. So you're like, well, that's 7 squared, isn't it? So you would go out to 7 and 7 and 7 and 7, and make even a bigger circle, right? Pretty easy. But is every circle in the middle? You know, so let's turn the page here. Well, guess what? Sometimes the circles aren't in the middle. Look at this circle. His middle, can you tell where his center is? I put, where is the center? And it looks like it's about right there, right? Doesn't that look about the middle? That point looks like, well, it looks like here's 0. So it looks like it's at 0 and up 2, isn't it? Now we can't plug that in because remember, they say this equation represents it. But this equation is for the points on the circle, like the Earth going around the sun. This is all the places the Earth's at. The sun might be at 0, 2. But look at the equation. And they wrote it up here also. And they want me to try all these points, but we're not going to. But look what they did to the equation. Look right in here. It's this. We still got 0, but it's up 2. But look, they wrote y minus 2, didn't they? This is a positive 2, but they put y minus 2. And after you go, well, this is kind of strange. Well, let's just see if it's true. They say if the center is at 0, positive 2, you put y minus 2. Well, let's grab a point on the circle and see if it's true. Let's grab this point here. I can read this point. That point. That looks like 0, 7. Let's see when the Earth is there, when the Earth's going around the sun. And let's get this off of here right now. In fact, we'll make them yellow like there's the sun. That's not yellow. There's the sun, right? There's the sun. So the Earth's going around. Does it go through 0, 7? Let's plug that point in. What do you get when you get 0, 7? Well, you get 0 squared is 0. What's 7 minus 2? That's 5. And isn't 5 squared 25? Every dot on here will work in this equation. And of course, the radius is still, it's still 5 away. Every dot's still 5 away. Now, don't worry if you're a little confused about that. Let's get this straightened out, figure out what's going on. Okay, so here's the rule if you're not at the center. Okay, so up here, we've got our regular rule, x squared, y squared is r squared. But if you move the center, or as we say, remember, translate, if you slide it over, this is the new equation, this big guy. Now, it looks a little complicated, but it's not. You don't have to solve it. All it says is h and k. The center is h and k, whatever the center is. Now, this is going to be much easier than it looks. Okay, look at this set. Look at that circle. Where is his center? And his center right now, if I look at it, his center looks like there's 2 and there's 1. So his center looks like he's at 2, 1, right? 2, 1. So what you're going to do, there's a minus built in. You just put a 2 there and a 1 there. In other words, let me go down here and write it. Down here, I'm going to write the equation. We're just going to go x, but he's not at the middle. X is at 2, isn't it? So we put x minus 2. You put the opposite sign. And the y is at 1. So you're going to put y minus 1. So instead of just doing normally x squared, y squared, you're going to make a little parentheses and just put the opposite of the center in the opposite of y. So if you see 2, 1, go x minus 2, y minus 1. And still put the little squares out there. And the radius, how far away is like the Earth from the sun? Or how long is the rope? And I see 1, 2, 3. It looks like it's 3 boxes away, doesn't it? Doesn't look like 3 away? So we put 3 squared. And some people just leave that, or you can change it to 9. And you don't have to solve it, but every dot on here works. I'm going to clean this up a little to make it look nicer. X minus 2, y minus 1 is 3 squared for that center. Now, if you don't believe it, let's pick a point on the circle. How about this point right here? How about that point right there? That looks like 5, 1. I'm going to say wherever that dot is, wherever you're at, every single dot on here will make 9. And if you're like, what? It still seems backwards to me. Okay, let's plug in 5, 1. Plug this point in and see if it makes 9. Okay, let's put a 5 here and a 1 there. If you don't believe, if you think it's backwards, let's see what happens. 5 minus 2, that's 3. 3 squared. Plus 1 minus 1, 0 squared. 3 squared plus 0 squared is 3 squared. It works. Every dot on this circle, every single dot is going to add up to 9. You could try more. Okay, so let's try another one. Let's do one backwards. Say somebody says, graph this green guy. And you're like, okay, x minus 4, y plus 1. Where should I move this circle? Whoops, I don't want to move that. I just want to move the dot. And I can't seem to grab the dot, okay? It won't let me grab that dot. Let me do this. Okay, here we go. Here's the circle. Where is he at? Where is he at? It says minus 4, doesn't it? So go to, not minus 4, go to positive 4. And now it says y plus 1. What do you think it's going to do? It's going to be exactly opposite what you expect. When you see this question and it says 4, you're going to think I need to be at positive 4 and negative 1. Okay, so the exact opposites, that's where the center is. So I'm going to go to positive 4, negative 1. That's my center. And then, oh, how big is the radius? Uh-oh, it's smaller, isn't it? 2 squared is 4. The radius here is only 2. So we're going to bring him in a little shorter. Make a little bit smaller circle with a radius of 2. Okay, here's one last one. Now with this blue guy, bring him over, okay? Where's this one at? Okay, so think about it. I'm going to move this circle out of the way. Where's his center? Look at these guys. What's backwards? How about negative 1, positive 3, okay? There's your center. So find that. You can do it on a little scratch paper. And if you don't have real graph paper, that's fine. You can just go like, if you don't have real graph paper, I'll do it without real graph paper in a second. Let's go back 1, up 3. There you go. There's negative 1, 3. That's the center. And the radius. What squared is 16? You should all be saying 4. All right, I'm just trying to write on the screen the best I can. You kind of like, that's 4 squared. So the radius is 4. So go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. And I'm off the paper. Uh-oh. And I'm off the top of my paper, aren't I? I can't get to that top dot. Okay. And so it's a nice little shortcut. I'm going to turn the page. We'll see it again. Okay, so can you name these? So this is where I want you to try it. Normally I'd have people come to the board and write them in, but we'll do one together. Number 1. Okay, so what do you got to do? And practice writing as you get used to it. Make a parentheses with a square. Plus, always make a plus. Another parentheses with a square. You see the white poster next to the orange poster? Over on the side wall, there's an orange poster. There's a white poster over there with the translation. Equals. Okay, so let's go find number 1. Here's number 1. Where's his center? There you go. So what's his x? I see a 3 and a 5, don't I? 3 and 5. 3 and 5. There's his center. 3 and 5. So go x minus 3 and y minus 5. So whatever it is, the opposite sign. And how long is his radius? How big is the rope? How far away is the planet? Looks like 2 boxes. So 2 squared. Or you can make it 4. Okay, can you fill in the rest? You could pause the video here. So you can ask Miss Lee, pause the video, take a few minutes to figure these out. And then in about 3 minutes or so, or when you're ready, I'll show you the rest of the answers. So I'm assuming you're pausing. Dun, 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 dun. Okay, welcome back. Hope you've paused it. Hope you've got all your answers. Normally I like to have people come to the board here, but it's not going to really work on the video. So I'm going to write these in. So here's the red guy. The red guy was x minus 5 squared plus y plus 2 squared. And his radius, he had a radius of 2. Equals, trying to make it equals 2 squared. Now you can also write 4 there. It's totally cool to write 4. Okay, 3 green, the green guy, he's at 0.8. So we don't have to do anything with the x. And then he's up 8, so y minus 8 squared. And he also has a radius of 2 squared, or 4. Okay, and 4, the blue guy, he's at -4, so x plus 4 squared. I'll put the little parentheses. Make sure you don't just look. If you don't, you got to make sure you write down. So you remember, I'll make a parentheses, make a square. And then he's up 2, so y minus 2 squared. So let me check that. A -4 is a positive, positive 2 is a negative. And he's also got the same radius. And now finally the yellow guy, which is bigger. Yellow guy, and whoops, I think I just erased his center. There's his center. He's at -3, so x, oops, I can't see that color. Okay, x plus 3, and I sure hope I don't make a mistake here, plus y, and he's -1, so y plus 1 squared. And his radius is 3, so 3 squared or 9. Okay, hope you feel like you got it. And this last one said graph him. You draw the graph. And you're like, what if I don't have graph paper? That's okay. I'll do one without graph paper. Watch this. I'm going to wipe out this paper here, okay? What if I went, whoop, and the graph paper weren't there, right? But the graph paper weren't there. Just go like this. Ta-da, you got graph paper. Okay, where's the center? I'm going to move this down just a little bit. At -2 and +6. And the radius is 4. So just go, okay, 1, 2, 1, 2, 3, 4, 5, 6, because they won't all fit on my little graph papers. There we go. -2, 6. And the radius is 4. Now I'm just going to go 1, 2, 3, 4. 1, 2, 3, 4. Just kind of guess it out. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Ta-da. And if you want, like if you're doing this on a quiz or something, you can even just say, or you're doing on your homework, just go like that and say it's 4 away. Just put like an arrow and say 4 away. And that's cycles. Let me see if there's one more slide. No, that's it. I think you got it. Okay. That's it. So that's it. Okay. So hopefully you enjoyed it. I'll put this guy back here so you can see them all. If you want to see the other answers, well, you can see them all now. I'm trying to erase that all out, but that's it.